Now the magic really starts to begin, and I'm very excited for this because why? This is what we've been building up to. We've been training, we've been doing a whole bunch of code, we've been working with data, we've been filling missing data, we've been turning it into numbers, we've been training countless machine learning models. Well, actually, probably about 5 or 6 in this notebook. But now we're finally going to use a trained machine learning model to make some predictions, right? This is where the magic in machine learning really comes down to, right? So what we're going to do is we're going to take our model here, the one that we've trained. We can run this again. So this is going to give us a score here. So this is training CLF on the heart disease data set, the X, telling our model to find the patterns between X train and Y train. Now what we're going to do, we've seen CLF.score. Now this is evaluating the model on the test data set, so data it hasn't seen before. So really what's going on behind the scenes with score is that the model is making predictions on the X test data, actually making something like Y preds, and then comparing them to Y test. Spoiler alert, we actually kind of have been making predictions, but now we're going to see them in the flesh. So let's go here. We'll write a comment, use a trained model to make predictions. Now there's 2 ways, real ways to make predictions with 2 ways to make predictions. We want to use, one is the predict function. Actually, there's a few more than this, but these are the main ones. Predict function. And then 2 is predict prober. We're going to look at predict first because this is the main one you want to use. How can we do this? Well, the beautiful thing is because of the beauty of the scikit-learn API, right? It's been designed amazingly. So kind of when you do one thing, that's why we could so easily sub out our model before, linear SBC for random forest classifier. Almost no matter what model we have here, there will be some kind of fit function, a score function to evaluate it, and a predict function. So, naturally, let's try call clf.predict. Now, what do you think predict might need to take? If we were trying to make predictions here, trying to predict whether or not someone had heart disease, what should we get our model to predict on? The important thing here is to remember what is our model learned on. And in our case, it's learned on these features. It's learned on these different body parameters or health parameters of a patient. And so it makes sense that predict function, in order for our machine learning model to make a prediction, it has to be passed similar data, actually the exact same data or same format of data that it has learned on. So let's give an example. This doesn't work. We'll make one that doesn't work to begin with. np.array, and we'll put some random stuff in here. 1, 7, 8, 4, well actually 3, 4. I was looking at 4, but press. Anyway, long story short, shift enter. This doesn't work. Why is that? Value error. Let's go down here. Expected 2D array, but got 1D array instead. It showed us our array. We put in there. Reshape your data using either array.reshape if your data has a single feature or array.reshape 1, -1 if it contains a single sample. But what we can do, we have some data in the correct shape already, and that's in the form of X test. So let's see. Let's remind ourselves before we pull the trigger, the shape of X test. Because remember, our model has trained on the training data and it has never seen the test data before. So if we want to make predictions, it has to be in this shape. So let's do it. What does this look like? What does this remind you of when we're making predictions here? Maybe not too much because it's just an array of zeros and ones, and that's all right if you're thinking that. But if we have a look at Y test, we've actually got the exact same thing. Maybe if we go np array, see if it'll format in the exact same way. Boom, there we go. So now, what we've done is we've made predictions on the test data to predict whether someone or not has heart disease, so 0 or 1. Now our labels are in the same format as our test labels. So our predictions are in the same format as our test labels. Now that's a bit of a mouthful, but you'll see why this is important. So now we can compare the predictions to the truth. In our case, this is the truth, right? The test labels. This is where we split our data set up above here. We split it here. And these are our predictions. So this will make a little bit more sense here once we put it in code. So compare predictions to truth labels to evaluate the model. It's kind of good practice to save predictions to something like ypreds. This is what you might see in documentation. clf.predict x test. And now what we're going to do is np mean ypreds equals y test. Boom. So now what are we doing here? We're making predictions here with our model, and we're comparing the predictions to the ground truth labels. Actually, I'm using a different word here, ground truth. That's another name for y. So I'm comparing it to the truth labels from our original data set. Take that down. Y is also referred to as ground truth. Maybe I should have put that up there with our nomenclature. But where does this number remind us from? Or where does this come from before? So we go clf.score x test y test. They're the exact same thing. Beautiful. So what we're calculating here is the accuracy, or just comparing how well the model did with this NP mean. We're going, hey, for each sample in here, did our model actually predict that label? So we can go through it manually and go 0, 0, yep, 1, oh, I got that one wrong, got that one right, got that one right, got that one right. And we could go on that. You could imagine if you had thousands and thousands of different labels. So we're not going to do that manually, as if we would ever do that. There's one more way of doing this. We can go from sklearn.metrics import accuracy score. And again, we'll cover metrics in I think it's the next section. We're getting ahead of ourselves. I was about to check what we're covering. We might do that now. Yep, evaluating a model is the next section. But for now, check it out here. Accuracy score, y test, y preds. Now, what do you think this will come up with if we're checking the accuracy score? If we go back here and press Shift Tab, returns the mean accuracy on the given test data and labels. So now, if we run this, boom, same thing. So 3 different ways here of doing the exact same thing. If we go here, y true, see that's where I got the true name from, right? The ground truth. In our case, our y true labels, or the labels that came with our data set, are in the test data, and our prediction labels are saved to ypreds. They've used ypred here in the doc string. So this is the accuracy classification score. Beautiful. So that is one way to make predictions with our classification model. So now let's see, up here, we said there was 2 different ways, predict and predict prober. We'll leave a little comment for ourselves, make predictions with predict prober. Now I'm going to save this for the next video, right, to make sure this one doesn't get a bit too long. But otherwise, I'll have a little practice with making some predictions, seeing if you can call the predict function with X dataset in the same format as the data that it's trained on. And I'll see you in the next video.